Everyone, this is P. Lakshminarayana. Welcome to my channel. Today we are going to discuss about how to write the molecular formula of the compound. Before the writing the formula of the compound, we have to know about the ions. What is ion? What are ions? An electrically charged atom or group of atoms which behaves as single unit with a positive charge or negative charge is called ion. Based on the nature of the charge on the ion, they are classified as two types. One is electropositive ion. Another one is electronegative ion. What is electropositive ion? The ion which having positive charge on it is called electropositive ion. It is also called cation. The ion which having negative charge on it is called electronegative ion. It is also called anion. Ions are also called radicals. Okay, cation is also called basic radical. Basic radicals. Anions are also called acidic radicals. Examples for cations: H plus, Na plus, Mg plus 2, NH4 plus, etc. These are all cations. Next one, examples for anions: O minus 2, N minus 3, H minus, CO3 minus 2. All are examples for anions. Another classification for the ions here: simple ions, compound ions. What is simple ion? If the ion contains one or more atoms of the same element is called simple ion. Examples for the simple ions: O minus 2, that is oxide ion; O2 minus 2, peroxide ion; O2 minus 1, superoxide ion. In these two ions, same elements are present, like atoms are present. These type of ions are simple ions. Next one, what are compound ions? The ion which contains one or more atoms of different elements is called compound ion. Compound ion examples: carbonate ion, sulfate ion, nitrate ion, and so on. Okay, here in carbonate ion, different elements are present. It is the combination of carbon and oxygen. So this type of ion is example for compound ion. Okay, now we have to discuss about the elements, how to get charges based on the valence electronic configuration and valence electrons. Okay, first of all, already we know the groups: first group elements, second group elements, 13 group elements, 14, and so on, 18 group elements. Okay, first one, valence electronic configuration of the first group elements: NS1. Second group elements: NS2. 13th group elements: NS2, NP1. 14th group elements: NS2, NP2. 15th group elements: NS2, NP3. 16th group elements: NS2, NP4. 17th group elements: NS2, NP5. 18th group elements: NS2, NP6. How many number of valence electrons in first group? 1. Second group 2. Third group 3. 14th group 4. 15th group 5. 16th group 6. 17th group 7. 18th group 8. Already discussed. Okay, any element which contain 8 electrons in their valence shell, that is more stable. Here also only inert gases 18th group elements have only 8 electrons in their valence shell. Remaining all are having less than 8 electrons in their valence shell. So they always try to get 8 electrons in their valence shell for the stability purpose. How to get stability? By losing or gaining or sharing of the electrons. Okay, here in first group element, how many number of valence electrons are present? Only one. Okay, here it get nearest inert gas configuration when it loses or gaining. If one electron lose easily or 7 electrons gain easily, 1 electron lose easily. If the atom lose the electrons, gets positive charge. If the atoms gain the electrons, atom gets negative charge. Here 1 electron lose easily, so it gets plus 1. Okay, here first group elements charge how much? Plus 1. Second group elements, how many number of valence electrons? Only 2. To lose easily, 6 gain easily, to lose, so losing means gets plus 2. Next one, 13th group elements, only 3 electrons. 3 electrons lose easily or 5 electrons gain easily, 3 electrons lose, that means plus 3. Here 4 electrons, here both possibilities, either plus 4 or minus 4. Here 15th group elements, 5 electrons are there, that means 5 electrons means 3 electrons gain easily when compared to 5 electrons lose. So these elements gets generally minus 3 charge. Next one, 16th group elements, 6 electrons in their valence shell, so only 2 electrons are required. Easily gain the 2 electrons, gaining means minus 2 charge. Next one, 17th group, 7 electrons are present in their valence shell. How many electrons are required? Only 1 electron required, so they gain 1 electron to get minus 1 charge. Next one, 18th group, not necessary. Why? They contain already 8 electrons in their valence shell, so generally 0. Okay, in exception cases are there. Okay, that can be discussed in next classes. Now first write the cations. In cations, first one monovalent ions, second one divalent ions, third one trivalent ions, fourth one tetravalent ions, fifth one pentavalent ions. Okay, already in first group elements, these elements are discussed. Okay, here name of the element and monovalent cation name both are same. Hydrogen H plus, hydrogen ion. Lithium Li plus, lithium ion. Next one, sodium ion, potassium ion, rubidium ion, cesium ion. Okay, next one, compound ions are present. If compound ions are present, if compound ions containing positive charge, name of that one ends with IUM, im. You remember that one. NH4 plus, ammonium ion, PH4 plus, phosphonium ion. If the element having lower oxidation state ends with us, Cu having 2 oxidation states, Cu plus 1 and also Cu plus 2. Cu plus 1 oxidation state Q plus. This one is also written as copper 1. Next one, Au plus 1, Rs or gold 1, Hg plus, mercurous or mercury 1, Az plus, generally it is known as silver. Okay, next one, divalent ions, second group elements all are having plus 2 oxidation state. Here plus 2, Be plus 2, beryllium, magnesium, calcium, strontium, barium, radium. Same element name and ion names both are same. Next one, chromium has more than one oxidation state. This one is lower oxidation state. Cr plus 2 is chromos, Mm plus 2 manganese, Fe plus 2 ferrous, Co plus 2 cobaltous, Ni plus 2 generally single element, Ni plus 2 nickel, copper plus 2 cupric, zinc, cadmium plus 2 oxidation. Generally they exist as plus 2 oxidation state, so they named as same as usual name of the element. Mercury having plus 1 oxidation state, plus 2 oxidation state, plus 1 oxidation state mercurous, plus 2 oxidation state mercury, mercuric, or another one mercury 2. Next one, here Sn plus 2 stannous, Pv plus 2 plumbous. Next one, trivalent ions, B plus 3, Al plus 3. As usual, boron and aluminium. Same. Name of the element and ions names are same. Arsenous, As plus 3 name is arsenous or arsenic 3. CO plus 3, cobaltic or cobalt 3. Here this name is cobaltic or write the cobalt 3. Next one, Au plus 3 name is auric or another name gold 3. Fe plus 3, ferric or iron 3. Next one, Cr plus 3, chromic or chromium 3. Next one, tetravalent ions, carbon, silicon, both are same as usual. Carbon name and silicon name is name of the element. Next one, Sn plus 4, already Sn plus 2 stannous, Sn plus 4 stannic or tin 4, Pb plus 4, plumbic or lead 4, Pt plus 4, platinic or platinum 4. Next one, pentavalent ions, As plus 5, arsenic, same. Name of the element is same and also this name is same, arsenic 5 or arsenic. Next one, Sb plus 5, antimonic or antimony. Next one, anions. In anions, first one, monovalent ions. Okay, generally any element having negative charge ends with IDE. These are all elements. F minus, fluoride, Cl minus, chloride, Br minus, bromide, I minus, iodide, H minus, hydride. Okay, any element having negative charge ends with IDE. Next one, these are all compound ions. HCO3 minus name is bicarbonate ion. HSO3 minus name is bisulfite ion. HSO4 minus name is bisulfate ion. HS minus name is bisulfide ion. H2PO2 minus 1 is the hypophosphite ion. H2PO4 minus 1 dihydrogen phosphate ion. CNO minus 1 cyanate ion. SCN minus 1 thiocyanate ion. O2 minus 1 superoxide ion. HO2 minus 1 hydrogen peroxide ion. OH minus 1 is hydroxide ion. Cn minus 1 is cyanide ion. Here ClO minus 1, ClO2 minus 1, ClO3 minus 1, ClO4 minus 1. Here ClO minus 1 is hypochlorite ion. ClO2 minus 1 is chlorite ion. ClO3 minus 1 is chlorate ion. ClO4 minus 1 is perchlorate ion. Like this, BrO minus 1, BrO2 minus 1, BrO3 minus 1, BrO4 minus 1. Names are also same. Hypobromite, bromite, bromate, perbromate. Like this, IO minus 1, IO2 minus 1, IO3 minus 1, IO4 minus 1. Name of these ions, hypoiodite ion, iodite ion, iodate ion, periodate ion. Next one, MnO4 minus 1, permanganate ion, N3 minus 1, azide ion. Next one, I3 minus 1, triiodide ion, NH2 minus 1, amide ion, BO2 minus 1, metaborate ion, AlO2 minus 1, meta-aluminate ion, NO2 minus 1, nitrite ion, NO3 minus 1, nitrate ion, CH3CO minus, acetate ion, HCO minus 1, formate ion. Next one, bivalent ions. First one, oxide, sulfide. These two are elements having negative charge. So ends with IDE. Next, O2 minus 2, peroxide ion. CO3 minus 2, carbonate ion. SiO3 minus 2, silicate ion. SO3 minus 2, sulfite ion. SO4 minus 2, sulfate ion. S2O3 minus 2, thiosulfate ion. Next one, S4O6 minus 2, tetrathionate ion. S2O7 minus 2 ion, pyrosulfate ion. S2O8 minus 2, per disulfate ion. SnO2 minus 2, stannite. SnO3 minus 2, stannate. PbO2 minus 2, plumbite. PbO3 minus 2, plumbate. B4O7 minus 2, tetraborate ion. C2O4 minus 2, oxalate ion. MnO4 minus 2, manganate ion. MoO4 minus 2, molybdate ion. SiF6 minus 2, fluorosilicate ion. Important, C2 minus 2 ion. This is acetylide ion. NH minus 2 ion, amide ion. Trivalent ions, N minus 3, P minus 3, B minus 3. These three are elements, elementary ions. So ends with IDE. N minus 3, nitride. P minus 3, phosphate. B minus 3, boride. BO3 minus 3 name is borate. Next one, AlO3 minus 3, aluminate. PO3 minus 3, phosphite. ion. PO4 minus 3, phosphate ion. Next one, FeCN taken 6 minus 3, ferricyanide ion. Next one, tetravalent ions, carbide ion, C4C minus 4, carbide ion. P2O7 minus 4, pyrophosphate. FeCN taken 6 minus 4, ferrocyanide ion. We will meet in the next class. Thank you for watching.